Okay, so now here we're looking at how to solve linear inequalities, and this is one of the topics discussed in 1.7. So here we're going to look at some more examples, some more detailed examples of how to solve these linear inequalities. Now, all the basic properties of linear inequalities already been discussed in class, so make sure you have all that notes aside as you're watching these videos here. So now I'm looking into my first example. Now we would like to solve the inequality 2x plus 5 less than 17. Now, in the world of inequalities, things going slightly different with solving equation. Now, solving equation, we are just looking for maybe one or two, or we're looking for a finite number of values for x, of possible values for x that makes the two sides equal. So that's how we solve equation. Now, when you're looking over to solving inequality, the difference here is that we're trying to find a whole family of x value. We're going to find a large collection of possible x value that makes the left side satisfying the inequality here with the right hand side. So in this particular probable inequality, what I'm looking for is I'm going to be looking for all possible x value, and that can be a lot of x members. But the point is, I'm looking for all possible x that satisfy the left-hand side less than the right-hand side. Okay? So now, to solve for that, now most of the steps here are carried out just like solving equations. So I'm going to need to subtract 5 from both sides. And here that gives me 2x less than, 17 minus 5, 12. So the inequality at this point still remains the same. Adding or subtracting the number from both sides is not going to change my inequality. And once again, this is one of the properties we already discussed in class. So here I am going to divide both sides by 2 to finally solve for x. And this time I'm dividing without worrying about changing the inequality because I'm dividing by positive numbers. So now my x here is going to be less than 6. So logically, so by the way, this is my final answer. This is my solution. This is my solution. My logical solution. What it means here is that all those x values that satisfy this inequality here is going to be any x values less than 6. So you can think about if you plug in a 5 to the left side, you're going to maintain the left-hand side less than 17. If you plug in a 3 is still less than 6, so if you plug that number 3 into the left side of the inequality, you're still going to maintain the left-hand side less than the right-hand side. But if you plug in, like say, x equals 6, then you are not going to get the left-hand side less than 17. Or if you plug in a number like say 7, then 7 now is higher than x. Now when you plug that into the equations, for sure, we no longer have the left-hand side less than the 17. So once again, the point here is that here we're talking about a whole family of values where the x has to be less than 6 to make the left-hand side here satisfying less than 17. Now, the other part in this problem here is besides solving this, we need to solve and graph the solutions. Right? So in this example, besides solving, which is the easy part, graphing the solution is a little more challenging. So the solution is right here. Logically, it means those x values satisfying this inequality has to be less than 6. So now, to graph the solutions. Draw for yourself a line of number. Okay. Now the number 6 is just anywhere there. You can choose it here. You can choose it here. It doesn't matter. It's just 6 is just one value on the line. Now, x is less than 6, so I'm taking all of those, right? Any values to the left side of 6 is possible. So I'm shading all of those domain to the left side of 6. I'm shading all that part to the left side of 6. Now, right at 6, do we want to include 6 in the set of solutions? The answer is no, because my solution here is indicating I want x is strictly the value of x, the values of x, are strictly less than 6. So now, I don't want 6. So here, according to the textbook conventions, we are using parentheses. And of course, the parentheses always, any parentheses always point toward the shading region. Okay, so here I'm having, that is my graphing of the solutions. Now, what about how do we express this? We also learn how to express this solution here in terms of interval notation. So, in interval notation, if you observe the line here, you can see that the shading goes anywhere below 6, anywhere to the left side of 6, and keep extending further to the left-hand side. So, and going infinitely to the left-hand side, I'm talking about negative infinity to anywhere less than 6. So that is my solution expressed as interval notation. Okay, so here's the graph, here's the final, here's the solutions in interval notation. Here is just basically the most basic solutions of the inequality. Okay, so example number 2. So this example, once again, you've seen all the detailed explanations in example 1. So now in this next example, allow me to reduce the amount of detailed explanation, and we're going to go straight into the point. Here we would like to solve and graph the solution. Okay, and then express, we want the, I'm saving myself some more writing, but we want to express the final answer in interval notation. So, the inequality that we have here is 8x minus 2 greater than or equals 14. So once again, I'm looking for all possible values of x that satisfy the left-hand side greater than or equals to 14. And so now, as usual, adding 2 to both sides, and that gives me 8x greater than or equals to 16, and then I need to divide both sides by 2. And that gets me x greater than or equals to 8. So once again, this is my final logical solution right here. That's my solution. But then this is just part of the problem. So logically, for any x value 8 or higher, then for any x value 8 or higher, you can plug it into the inequality here and satisfy the left-hand side greater than or equals to 14. So now, the point now is that, so to graph the solutions, once again, draw for yourself the line. And 8 here is going to be the borderline number. So put 8 anywhere on the line. It doesn't matter where you put it. You can put it all the way here, you can put it all the way here, but there's just that number 8. And then here's it's indicating x greater than or equals 8. So for sure, we want values to the right-hand side of 8, because anywhere larger than 8, it appears to the right-hand side on the number line. And then this time, since the inequality, the final inequality is saying x greater than or equals 8, so I do want to accept 8. 8 is also included as part of the solution values. So now I'm going to use parentheses right on 8. And of course that parentheses is, square bracket, I am sorry. But the square bracket, once again, it's pointing toward the shading regions. So here's how I graph the final solutions. Here's how I graph the solution of the inequality. And then the interval notation for the solution is going to be 8 to infinity, comma infinity. And always parentheses on the infinity side. And here brackets on 8. And that's how we define our solutions. Example 3. Okay, we would like to solve and graph again. And then once again write the final answer in interval notation. So the inequality I have here is 18x plus 45 less than or equals to 12x minus 8. So now in this inequality right here, you can see that the x terms are all over, and we have things are all over the inequalities. So now, just try to, as usual, just similar to what we've been doing with inequality. A lot of times we try to bring all the x together on one side and on the non-x to the other side. So I can subtract 45 from both sides, and at the same time I can subtract 12x from both sides, and that gets me 12x minus 8x. That gives me 6x. less than or equals to, now minus 8 minus 45 is going to give me a minus 53. Okay? And so to solve for x, once again, I just need to divide both sides by 6. So my x here, the solution for x is going to be, for any x value less than or equals to minus 53 over 6. That is going to work. That is going to satisfy the inequality, making the left-hand side less than or equals to the right-hand side. So here's my logical solution. However, so the next task here is to, once again, graph the inequality. So think about the graph. And once again, you don't even have to know precisely where this negative 53 over 6 is going to be on the line. It can be just anywhere here, negative 53 over 6. It's just one value that's going to be existing on the line of numbers here. And then this time we want x to be, any x value is less than or equals to negative 53 over 6. So I'm going to shade, of course, to the left-hand side. And then I'm leaving a brackets right on 53, negative 53 over 6, because once again, negative 53 over 6 is included as part of the solution. So now that's how I graph it. And then finally, writing that solution here as in interval notations. We have, so the graph is telling it off, right? The shading here extends starting at negative 53 and keep extending all the way to the left infinitely. So we have negative infinity, comma, negative 53 over 6, brackets on negative 53 over 6, parentheses on negative infinity. And that's how we are done with it. With example number 3.